The world just witnessed the impossible. A 70-meter rocket didn't just launch, it hovered midair, balanced on fire, and landed with precision. This is Starship Flight 11, SpaceX's most ambitious test yet, and the moment reusability became reality. Section 1. The mission Starship Flight 11. Starship Flight 11 wasn't just another test. It marked the end of the Block 2 era and the start of SpaceX's next-generation Starship, version 3. After years of testing and iteration, SpaceX was ready to prove full-scale reusability. At dawn in Boca Chica, Texas, Booster 15 and Ship 38 stood on Pad 2, a 122-meter stainless steel rocket, taller than a 40-story building and the most powerful ever built. When ignition came, 33 Raptor 2 engines erupted beneath the booster, unleashing 7,500 tons of thrust, more than twice that of the Saturn V. The rocket rose through the Gulf sky, its fiery trail glowing across the horizon in what observers called the event shower. Flight 11's goals were clear. Reach orbit with a full-stack launch, test a dummy payload system simulating Starlink and deep space cargo, and attempt a new landing burn to advance reusability. But the real surprise came later, when SpaceX revealed a maneuver no one expected, a controlled hover of a 70-meter booster, balancing perfectly on fire. Section 2. Starship V3 and Raptor 3 evolution. Flight 11 marked the grand debut of Starship version 3, a bold leap forward in both design and philosophy. Every part of this vehicle, from its polished hull to its hidden circuitry, was a reflection of SpaceX's relentless pursuit of strength, intelligence, and reusability. The new structure was forged from upgraded stainless steel alloys, lighter yet stronger, built to endure the punishment of repeated launches and reentries. Inside, a new generation of flight computers brought the ship to life, giving it split-second reflexes during ascent, stage separation, and descent. Starship was no longer just powerful, it was self-aware in the air. At the center of this evolution were the Raptor 3 engines, masterpieces of modern engineering. Each engine produced more thrust, burned cleaner, and operated with simpler plumbing than ever before. The design reduced heat stress and made maintenance faster, turning what once took weeks into days. For SpaceX, this was the key to achieving their ultimate goal: rockets that could fly, land, refuel, and fly again like commercial aircraft. Flight 11 also introduced a daring new maneuver known as hot staging. As the booster continued to fire, the upper stage engines ignited before separation, handing off thrust like a runner passing a baton without slowing down. The transition was smooth, powerful, and efficient, cutting down on mechanical shock and maximizing every drop of fuel. No other rocket in history had pulled off something this complex at this scale. Even the look of Starship told its own story. The bright orange coating on its belly wasn't just for show. It was a thermal layer designed to shed heat and protect against the violent temperatures of ascent and reentry. It was armor, not paint, a visual signature of innovation in motion. All these upgrades together laid the groundwork for what comes next. Version 4. Starships, machines built not just for Earth orbit, but for the Moon, Mars, and beyond. With V3, SpaceX proved that full reusability was possible. With V4, they're preparing to extend humanity's reach across the solar system. Section 3. Booster 15 and the hover maneuver. Booster 15's hover test was the moment that stunned the world. It wasn't just another landing attempt, it was the first controlled hover of a rocket this size. A 70-meter-tall stainless steel tower, perfectly balancing above the ocean, defying gravity with precision. As it descended toward the Indian Ocean, SpaceX executed a mid-descent relight. Multiple Raptor engines reignited together, their thrust balanced to slow the fall and hold the booster in place. For a few seconds, it looked unreal, a rocket frozen midair on a column of fire. Each Raptor was throttled and gimbaled individually to counter even the smallest drift. Imagine balancing a skyscraper on one finger, adjusting every split second except these muscles, were engines producing millions of pounds of thrust. This wasn't for show. The hover maneuver provided data that will directly refine Mechazilla's catching system, the tower that will one day grab returning boosters mid-air instead of recovering them from the ocean. Across the industry, the reaction was unanimous: disbelief, then admiration. Engineers summed it up simply: a hovering skyscraper rocket? That's SpaceX. Section 4. Ship 38 upgrades and reentry. While Booster 15 captured attention, Ship 38 quietly achieved one of SpaceX's most important milestones. It proved Starship's heat shield could survive full orbital reentry. After Flight 10 exposed problems with tile adhesion and stability, SpaceX redesigned the system. Each tile was now attached with micro-lock fasteners that flexed under stress instead of breaking loose. With over 1,000 tiles produced daily at Starbase, reliability had become part of the assembly line. As Ship 38 re-entered at high speed, its aerodynamic fins guided the craft through rolling maneuvers to spread heat evenly. Temperatures reached up to 10,000 degrees Celsius, creating a violet-pink plasma glow across the belly. For several minutes, communication went dark, a standard plasma blackout. Then, contact returned. Ship 38 had survived intact. No major tile losses. No structural damage. For the first time, a Starship heat shield endured full orbital re-entry without failure. SpaceX had turned the most dangerous phase of flight into routine success. Section 5. Payload tests and orbital reusability. While the hover test drew headlines, the most significant progress happened in orbit. Starship Flight 1 carried 8 dummy Starlink simulators to test its payload deployment system under real conditions. For the first time, SpaceX fully operated Starship's payload bay door in space. The massive hatch opened and closed flawlessly, proving the system could function in the vacuum of orbit. This test wasn't just about payloads. The same system will one day enable orbital refueling, Starship's docking, transferring cryogenic propellant, and extending missions beyond Earth orbit. The implications are massive. Refuel once, and the moon becomes routine. Refuel again, and Mars is within reach. Flight 11 proved Starship is more than a launch vehicle. It's the backbone of a reusable transport system, built to move cargo, satellites, and eventually people across the solar system. Section 6. Performance and flight data. From liftoff, Starship Flight 11 exceeded every expectation and broke several records along the way. Within just 60 seconds, the combined thrust of 33 Raptor engines pushed the rocket beyond 1,000 kilometers per hour, slicing through the lower atmosphere with raw power. As it climbed past 7 kilometers, Starship faced max Q, the point of maximum aerodynamic stress, where the air pushes hardest against velocity. This is the true test of a rocket's strength. And Starship held steady. Its titanium grid fins and reinforced hull absorbed the immense pressure without a single sign of strain. At T+2 minutes and 20 seconds, SpaceX executed one of the most complex maneuvers in rocketry: hot staging. 13 central Raptor engines ignited before stage separation, keeping constant thrust through the transition. It was the equivalent of passing a baton mid-sprint without slowing down. The result was smoother separation, minimal shock, and a boost in overall efficiency. By T+4 minutes and 30 seconds, Booster 15 reached its second milestone, proving that reused Raptor engines could still perform flawlessly after enduring extreme heat and vibration. Moments later, telemetry confirmed orbital velocity at 24,600 kilometers per hour. The celebration at Starbase and Hawthorne was quiet but meaningful. Every engine had worked perfectly. 0 failures. Full thrust from start to finish. It was a defining moment for SpaceX. For the first time, a rocket achieved complete propulsion reliability, something even the Saturn V never reached. And with 3 times its thrust, Starship had officially redefined what maximum performance means in rocketry. Section 7. Landing and splashdown. As Starship re-entered the lower atmosphere, its descent was calm and precise. SpaceX's latest subsonic control software guided every motion of the flaps and thrusters in perfect coordination. Then came the moment that stopped the world: the relight and hover burn. Booster 15 reignited its Raptor engines in flawless synchronization, holding itself perfectly steady above the Indian Ocean. For a few seconds, the most powerful rocket ever built hovered in place, a steel giant balanced on fire. Moments later, it descended slowly and touched down in the water with near-perfect accuracy. Engineers at Starbase called it poetry in motion. To put it in perspective, Falcon 9's first landing in 2015 changed spaceflight forever. But this went beyond that. A 70-meter rocket landing vertically was once a miracle. Now, a 122-meter super heavy rocket could hover midair and descend with precision. It wasn't just a landing. It was a preview of what's next. A future where reusability isn't an achievement, but the standard for interplanetary travel. Section 8. Implications and future. Starship Flight 11 wasn't just a success. It was proof of concept for the future of space travel. Every major system, from hot staging to heat protection, from orbital payload delivery to the hover burn, worked together flawlessly. It validated the dream of full orbital reusability. With this mission, SpaceX has built the foundation for what comes next. The same systems that allowed Flight 11 to survive fiery re-entry and relight in midair will soon power NASA's Artemis missions, delivering landers and cargo directly to the lunar surface. Beyond that lies the next step: Mars cargo and crew transport, the beginning of humanity's journey toward becoming a multi-planetary civilization. These technologies aren't designed for one-off missions. They're built for sustainability. Each breakthrough in reusability brings us closer to permanent off-world settlements, where starships carry supplies, habitats, and eventually people between planets with the dependability of airliners. The next leap is already in motion. Starship version 4 will feature greater delta V, faster turnaround times, and longer operational lifespans, pushing the limits of reusable rocketry even further. One figure says it all. Flight 11 achieved a launch cost of just $93,400 per kilometer of cargo, the lowest in spaceflight history. In one flight, SpaceX didn't just prove reusability works. It proved that space can finally be affordable. Section 9. Industry reactions. The aftermath of Flight 11 sent ripples through the aerospace world. Within hours of the hover footage going public, engineers from Lockheed Martin and NASA praised SpaceX's precision and control, calling the hover burn a landmark in propulsion engineering. Analysts described the mission as a defining moment for reusable rocketry, comparing it not to the moon landing in distance, but in technological significance. When the data was revealed, the comparison became undeniable. The Saturn V once represented the peak of power and scale. Now, Starship has surpassed it, delivering greater thrust, control, and reusability than any rocket in history. Across the industry, one statement echoed above all: SpaceX didn't just break records, they rewrote the rules of rocketry. Starship Flight 11 proved the future of spaceflight is here. From launch to hover to splashdown, it redefined reusability. This was the dawn of a new era in rocketry. Which moment amazed you most, the re-entry, the hover, or the descent? Space will never be the same again.